Hello again, year 7. Can't believe this is our last lesson of the year and I'm not going to be there to see you, but I know you're going to do a great job anyway because you always do. So you've got your starter on this first slide here. So do now 3, 2, 1. So first one you have to name 3 things, second 2, last one 1. Obviously you can pause the video while you do this. I would highly recommend that. Okay, so here's your answers. Doesn't matter what order. 3 subatomic particles, proton, neutron, electron. 2 gases exchanged during breathing, carbon dioxide and oxygen. 1 product of photosynthesis. Hopefully you went for glucose, the main one. Otherwise you could have gone for oxygen. Quite straightforward. I know you've got that. Now you've got 4 objectives this week. You've got to know what current is, know the symbol and units for current, know what is needed for current to flow, and complete the challenge task. Now one tiny little thing I'm going to point out to you, current, when it's electricity, has an E in it, not an A. Otherwise we're talking about a piece of fruit, a dried up grape. So please make sure you've got that E for electricity whenever you write current. Now here is our topic map. We've been doing our mind map. You should have something similar to this at the front of your book. We've got the 4 sections. We've already got potential difference. We've already got charge. We've got resistance and currents left, and current is what we're looking at today. That's why it is in green. You'll be adding your own words at the end. Quite straightforward. They're in the task at the end, so I'm sure you can manage that. Now, current. If you have a potential difference and charge can move, so not just one of them, but both of those, it's an and, then the charge will move as a current. So current is simply a moving charge when there is a potential difference. It has the symbol I, which seems a bit weird because it's current, but it was first named in French and it was named as the intensité du courant, and the first letter of that is the letter I, hence the symbol being an I. It is the rate, so that means the speed, the amount over a certain time, flowing in a second, and it is measured in amps because it's Monsieur Ampère who first did this, and that is the Frenchman who also chose the symbol I. Now there has to be an unbroken circuit, so if you're sitting at home and you've got your lights off, you've got a switch and it's on the off position, and that breaks the circuit to stop the current flowing. As soon as you press the switch to the on position, it completes the circuit and your lights will come on. And the current that leaves the component is the same as the current that enters it. So the current isn't used up, it stays the same. The only time the amount of current will change is if one circuit splits into 2, or if 2 pieces of circuit join together. And this is important when you are wiring up things such as houses, but it's really simple. If it splits into 2, then the total current in the 2 parts of the split will be the same as the current before the split. And if 2 join together, you just add together the current of the 2 smaller parts to find the current of the new joined part. There is a video clip here all about electric shocks in nature. It is an electric eel, and this, I would recommend you watch this because this gives you a little bit of information before you get on to our writing task, which is our main task today. So here we go. I shall read it to you because this is so weird. It's untrue. There's a couple of tricky words, so listen carefully to our lovely science story. A newly discovered species of electric eel produces the highest potential difference of any known animal. Not sure if the one I showed you was this one, but they were the same. Potential differences of up to 860 volts have been recorded. They produce it using specialised cells called electrocytes. And these eels can grow up to a scary 2 meters in length, so I certainly wouldn't want to meet those while I was swimming. Electric eels live in the fresh water of South America. Fresh water means rivers, not the sea. They use the shock for defence against other predators and to catch prey such as small fish. The small fish feed on the plants, and humans are pretty much the only predators for the eels. People do like to eat eels. Now you've got 2 things to do in the task at the end. To describe a typical food chain involving an electric eel, that's a bit of revision. Always nice to get a couple of topics joining together. Also describe how we might test an eel to see what potential difference it can generate. Now remember, we are not going to harm the eel during the test. Nothing too extreme, please, Year 7. Now, you can produce your answers, the food chain and the test, as straightforward writing, or a poster, a song, a video, a newscast, a blog. Just thought about that because you are obviously pretty cool, hip and trendy kids. You have got some words to use. They've got numbers next to them. That is the score you get for using that word. So producer and consumer each get 1 point. That's not vocabulary from this challenge, this topic, so I'm sure we know which part of the challenge that goes with. Habitat, herbivore, 2 points each, as is voltmeter. Might give you a little bit of a clue how to test it. Energy flow, current and specialised cells are 3. If you want to name the specialised cell for a bonus point, that is already included in the writing. Now, I'm really looking forward to seeing what you produce here, and I've got some very exciting news for next year. You are going to stay together as a class for science, and you're going to have 2 teachers, and one of them will be me. So please do a good job on this. Have a great summer holiday, guys. Can't wait to see us all back together at school in September, but make sure between now and then you stay safe and stay away from these electric eels, please. Take care. Bye for now.